Hello dear students of +1 medical and non-medical respected teachers। उम्मीद है सारे चढ़ती कला च होवोगे। तो आज का टॉपिक है projectile motion। So in this first video I will discuss horizontal projection. In the next video I will discuss angular projection। So पहला projectile हुंदा की है? Projectile means any body thrown with some initial velocity and then allowed to fall under the effect of gravity. That is called a projectile. For example, bullet fired from a gun, a bomb dropped from an aeroplane, a javelin thrown by an athlete, hammer thrown by an athlete. Any stone thrown in any direction then allowed to fall under the effect of gravity alone is known as projectile. So projectile motion is of two types. Number one is horizontal projection and number two is angular projection. So to discuss horizontal projection, suppose we are standing at certain height h and a projectile is projected with initial velocity u in the horizontal direction from this height h, that is point O. Now as soon as the projectile is projected, it comes under the action of two motions. One is uniform motion along x-axis. Along x-axis means there is no acceleration along x-axis. Another is uniformly accelerated motion along y-axis because of gravity. That is acceleration in the vertical downward direction ay is equal to g, acceleration due to gravity. So any projectile when fired horizontally, it comes under the action of two motions. One is uniform motion along x-axis and other is uniformly accelerated motion along y-axis. Now suppose it follows the path OPB and suppose it is at P at any instant t and coordinates of P are x and y, means it covers horizontal distance x and vertical distance y, because when projectile heads forward it follows horizontal as well as vertical distance. Then at point O, velocity along x-axis is u, that is component of ux is equal to u only, and component of velocity in the vertical downward direction is 0 at initial point O. At point P, suppose v is the velocity at that instant, because velocity will change. Let Vx is equal to component of velocity along x-axis, which is equal to u. Vy is equal to component of velocity along y-axis at point P. Let beta is equal to angle which resultant velocity v makes with the horizontal direction, that is velocity u vector or vx vector. And this distance yb is called horizontal range, the distance of the point where its projectile strikes the ground from the foot of the tower of height h. Then first of all we'll discuss what will be the trajectory of the projectile. So trajectory of the projectile, to understand trajectory of projectile, suppose px by v any point and using x is equal to ut plus half at square equation of motion. So we have x is equal to horizontal distance covered at any time t, x is equal to ut, velocity in the horizontal direction u, t time, but there is no acceleration, so plus 0, so is equal to ut. So x is equal to ut at time t, or t is equal to x upon u. Say this is equation number 1. Now for vertical motion, y is equal to initial velocity 0, 0 plus half gt square, substitute value of t, x upon u, x square upon u square, so g upon 2u square into x square, or y is equal to kx square, where k is a constant of proportionality because u is constant, g is constant, and y is equal to kx square, which is nothing but equation of a parabola, and this parabola is symmetrical to vertical axis, that is y-axis. This means trajectory of the projectile fired horizontally is parabolic in nature. So it will be a parabolic path. Then time of flight. Time taken to reach the ground from the point of projection is known as its time of flight. To find time of flight, vertical distance covered by the projectile is h during this time. So using again s equal to ut plus half at square. So for vertical motion we have h is equal to 0 plus half g capital T square, or t is equal to 2h by g under root, which is the required expression for time of flight of horizontal projectile. Then horizontal range. Horizontal range is yb. Yb, distance between the point B where projectile strikes the ground and the foot of the tower. So yb is equal to horizontal range, horizontal distance covered by the projectile, maximum horizontal distance covered by the projectile. Using again s equal to ut plus half at square. We have s equal to r, distance covered. You should also u, t is capital T, and a 0 in this vertical motion. So u into under root 2h by g, time of flight, or it will be 2u square h upon g, which is the required expression for horizontal range of projectile. Now velocity at any instant. So velocity at any instant given by v is equal to x component square plus y component square square root. But Vx is equal to u and Vy is equal to gt, because using V is equal to u plus at, initial velocity in the vertical direction 0, so Vy will be equal to gt only. So it will be V is equal to under root u square plus g square t square. So knowing initial velocity of projection and time, we can find velocity at any instant. At beta equal to angle between resultant velocity and the horizontal direction, and tan beta will equal to vertical component over horizontal component Vy upon Vx by perpendicular base. So Vy upon Vx or gt upon u. Again, knowing u and t, we can find direction of the velocity. This shows that velocity of the projectile will be different at different times. So this is all about horizontal projection, and you have to remember all these formula for numerical problems, and derivation may also be asked for subjective question. So all the best, be happy. In next video I will discuss angular projection in detail. All the best. Stay tuned. Good luck.